Hey everybody, Mrs. Bixler here, and we are starting your second to last section in Chapter 9, also known as Unit 8. So Section 9.6 is about other angles. So remember, we first talked about central angles, and those are angles whose vertices are in the center of a circle. And remember, central angles are the same measurement as that intercepted arc. And then we took that vertex and we shifted it from the center all the way to one side, and we called that an inscribed angle. And remember, the inscribed angle is half the measurement of that intercepted arc. So now we're going to take that vertex and we're going to pull it a little bit further. So now what happens when our vertex goes outside the circle? So we could have, and we'll talk about this more in the next slide, but we could have a situation that looks like this. So now we have two intercepted arcs. And then what about, okay, so we've got a vertex in the center, a vertex on the circle, a vertex outside the circle. But what about if our vertex was somewhere within the circle? So what if my vertex was like, I don't know, here, and it was made up of two chords crossing? So we've got different situations here. We've got an angle here, an angle here, an angle here, and an angle here. So let's talk about these two lower ones. So this is what section 9.6 is all about. It is two theorems, and that's it. So theorem number one says, if you have an angle, I'm waiting for it to shift. There we go. So if you have an angle whose vertex is outside the circle, and it does not matter if that angle is made up of two secants, the way this top one is, this middle one is made up of a secant and a tangent, and this bottom one is made up of two tangents. It does not matter. The measurement of that exterior angle is going to be, and this is a little weird, but is going to be half the difference of those two angles. So that equals the measurement of angle 1. Angle 1. Cool? So whenever your vertex is outside the circle, you're going to subtract the two arcs, and then you're going to divide them by 2, and that's it. So that's theorem 1. Theorem 2 is when the vertex is somewhere within the circle. So here's our vertex somewhere inside my circle, and with this one, this is going to be the average of those two intercepted arcs. So it's going to be x plus y divided by 2. So that's going to be the measurement of angle 1. All right, so those are pretty straightforward. Let's do a quick recap just to remind ourselves. So we have 4 different situations here. We have when our vertex is on the center, and I know that the center and that intercepted arc, that central angle and intercepted arc, are going to be the same. Next, we have when our vertex is on the circle, and that's an inscribed angle. And so I know that that inscribed angle is going to be it's going to be half the measurement of that intercepted arc. So the arc will be twice the measure. When my vertex is outside the circle, remember this one's going to be like the smallest. So that's you're going to keep it in mind. So it's going to be the difference of those two arcs, A minus B divided by 2. And then when my angle is somewhere within the circle, and a way to remember this is you know that that angle then has to be a little bit larger because you've now sucked that vertex back in. So this is going to be the average, or C plus D divided by 2 of those two intercepted arcs. All right, so here is the general overview, and I'm going to give you 4 problems to do here. So I want you to pause the video and solve for angle X, angle Y, angle Z, and angle W. All right, so you're back. So hopefully with angle X, you realize that your vertex was somewhere within the circle. So you add up the intercepted arcs and then divide by 2. So you get the measurement of angle X is 70 degrees because 110 plus 30 is 140 divided by 2. Yeah. Great. All right. Now for the second one, you saw that your vertex was outside the circle. So here I'm going to subtract my two arcs. So I have 120 minus 40, which is 80, and then 80 divided by 2 is 40. So the measurement of angle Y is going to be 40 degrees. All right, what about this one? The vertex is still outside the circle. Even though this is a tangent and a secant here, don't worry about it. So 200 minus 60 is 140. Oh, again, so 140 divided by 2 is 70. So we get Z equals 70 degrees. And then here, last one, the vertex is still outside the circle. So 260 minus 100 is 160, and 160 divided by 2 is 80. So I know that W is going to be 80 degrees. Now, if you noticed this one, sorry for the weird 8 there, weird. So if you noticed with this bottom right-hand corner, we saw ones kind of like this before, and it looks just like a really sweet treat. A little ice cream cone. Remember these? So whenever you have this angle on the outside, this near intercepted arc is going to be supplementary to that exterior angle. So X is going to be 150 degrees. Cool, remember that? All right, so let's take a quick peek at something like this. So this is a little bit of a different problem. I want you to pause the video and try it on your own. All right, so we're back. This one looks a little different because now we're not solving for this angle. But remember, your vertex is on the outside, so it's going to be the difference of those two intercepted arcs divided by 2. So the way you'd set this guy up is you would just say x minus 21 divided by 2 equals 32. And then you cross multiply, you divide, etc., you solve, and you're done. Good? All right, I'm going to leave you with this beauty. So you can take a screenshot of this, or you can go ahead and try and print this out if you would like. I can email it to you. But here is an example of a crazy problem. You now know how to solve for all of these missing angles, which is pretty incredible. We'll do this together in class, don't worry. And there are also some pretty insane angle chasers that we'll work on too. So you're going to crush it. Go work on the worksheet, and I'll see you soon. Thanks.